Hello everyone, in this video we're going to learn about trees, yet another kind of data structure. Let's begin with the definition of a tree. So a tree is containing like several nodes, as you see in the examples that I draw here, tree number 1, T2, and T3. So each node is connected through some arcs or some edges to some other nodes. We have one node that we call the root. As you see in the tree T1, the node N1 is the root, and in the T2 and T3 also the node N1 is the root. So the root is the very first node of the tree, the one that we have access to it at any time. And as you see in trees T2 and T3, nodes N2 and 3 are connected to the node N1, same thing in the tree T3. So N2 is the child of the node N1, and N4, N5, and 6 also are the children of node N2. So we call these like the arcs, also edges, or just an edge for one arc. So N1 has two children, N2 and 3, and N2 and 3 are connected to the N1 through these edges or arcs. So we're going to also learn about some definitions and some concept about the trees. For example, what is a leaf? A leaf is the node that does not have any child. So in the T1, the node N1, at the same time that it is the root, also is a leaf. So in tree number or tree T2, nodes N4, N5, N6, and 7s are the leaves. And in the tree T3, N4, N5, and 6 are the leaves. So we call N2 and 3 the parents, and also N1 the parents in the nodes in the trees T2 and T3, or also, as I said, N4, N5, and 6, they are called the children. So a node can be both the parent of some other nodes, and it can be also a child of another like the node. So as we see here, a node only has one parent, but it can have more than one child, or zero child. So 0 up to other number of children. So T3 is a very special like the kind of tree. We call it a binary tree. So what is a binary tree? It is a tree that each node at the maximum has two children. So either a node has 0 child, or 1 child, or 2 children. So node N1 has 2 children, N2 also has 2 children, N3 has only 1 child, but N4, N5, and 6, as we see here, all of them are leaves and they don't have any children. So we're going to talk about the binary trees in other videos, so hopefully you can watch my other video about like the binary trees. So let's talk about some other concepts also in trees. So we're going to talk about the level of a node, we're going to talk about the height of a tree, we're going to talk about the length or the path for a node. So what is a path? A path is the unique like the sequence of like edges that you need to pass in order to, or travel in order to reach a node from the root. For example, in the T2, 3, if we want to go to the node N6, we need to take these edges, so from N1 to N2 and from N2 to N6. In the tree T3, in order to reach N6, we need to go from to left N1 to N3, and then here to the N1 to N3 to the right, and from N3 to the N6 to left. And that's the path from the node N1 to N6. So, and we're going to talk about the height of the tree, or let's talk about the depth and the level first. So the depth or the level is the number of nodes from the root to that node. So, for example, in the T1, as we see, N1 is at level 0 or at the depth 0, because the number of nodes that we need to travel or to visit from the N1 to visit N1 is actually 0. So let's write it here that in this one, it is at the depth or the level 0. So L is 0 and also the depth for the N1 is 0. Let's look at the node N1 and N1 on the two other threes. Again, same thing is 0 and also L is 0. So again, depth or level is the number of nodes that you need to pass in order to reach that one, to reach that node from the root. In the tree T2, N2 is at the depth number 1, and also the length that we need to go from N1 to N2 is also 1. So we can see that N4, N5, N6, and N7, both all of them are at the depth 2 of the tree, and also they are at the level 2 of the tree. So what is the height of the tree? Height of the tree is the depth of the deepest node in the tree. So here at the node plus 1. So here the T1 has the height of 1, which is, so I'm going to write height is equal to 1 for the node for the tree T1. So the height is the depth of the deepest node in the tree plus 1. In the tree T2, as we see here, the deepest node, which in this case N4, N5, N6, N7, all of them are the deepest part of the tree, has the depth of the 2. So the height of the tree will be 2 plus 1 will be equal to 3. Same thing for the T3. Also, it has the height of 2 plus 1, which is going to be 3. So we're going to see the use of like the height and also the level and interesting things, especially in the binary trees, that how actually they can just provide us some interesting concept and theorem about like the way that the binary trees or some other trees that are working. Here is a very simple implementation of or declaration of just the main concept of the trees. So we have the class tree, which is again is a generic class. As I have mentioned in my other videos, or you may have watched it before, I'm using almost a very similar code to the Java, mostly or very close to the Java language. Here, the class T generic means that the type of the data of like the each node will be assigned later. So the class tree has the root, which is a node, and that's the only thing that we need. Although, if you want to go to full implementation, we might want to keep the size of the tree, for example, how many nodes we have inside the tree, or maybe some other information. Again, here are just the very important or the most fundamental part of the tree. And then each node itself is a class, which like we have the data from the type T again, and we have a linked list to store the children. If we know the maximum number of the children, maybe we can just use an array instead of a linked list. But if the number of linked lists is not known ahead of time, or it might vary a lot. For example, one node might have only one child, the other might have like the 10 children. It's a good idea to keep actually the children in a linked list just to save some memory. Although again, you can use an array for keeping the children. In some other videos, I will explain or I will go more to the details of like implementation of like the trees, and maybe explain some methods such as the insert or the delete methods. Make sure to watch my other videos, especially about the binary trees implementation, also binary binary search trees.